This video will show you how to find the gradient between a pair of coordinates. So first of all, I need a pair of coordinates. I'm going to start off with 1, 1 and 3, 5. Okay, so I've got two coordinates there, and I'm going to connect them with a straight line. That will give me a line segment, and that's what I want to do. I want to find the gradient, the steepness of that line segment. So what I'm going to do is turn it into a triangle. Okay, and I can see that the height of my triangle is 4 and the base of my triangle is 2. Okay. Now the gradient is the steepness. What we're literally looking at is the distance climbed in 1 unit across. So how many units have gone up in 1 unit across? Which means it's a compound measure like speed or like density, and it's a division measure. And to find the gradient, to find the steepness, we look at how far up it's gone, which is the change in y, the vertical change, and we divide that by the change in x, which is the horizontal change. Okay, so the change in y is the height of my triangle, which is 4, and the change in x is the base of my triangle, which is 2. So I end up with 4 over 2. 4 divided by 2 is 2. Okay, fantastic. We can do that, not a problem. It's positive 2 because the line is going upwards. If the line was going down, then it would be a negative gradient. Let's have a look at an example like that. So I've got my first point, which is going to be 1, negative 2, and then my second point, which is going to be 4, negative 3. Okay. Okay, so once again I'm going to turn it into a triangle. Okay, and my height is 1 and my base is 3. So to find my gradient, we say change in y, which is 1, divided by the change in x, 3. Now that's a fraction, 1/3. But this triangle is sloping down, which means that it's got a negative gradient. If it's going up, it's positive. If it's going down, it's negative. We can do this without having to draw a graph, and I'm going to show you how to do that now. So my final one I'm going to look at is these 2 points here, negative 5, negative 5, and negative 3, negative 2. So I'm going to write those two down. And you'll notice I'm writing them underneath each other. Okay, there's a reason for that. Now remember, this is our x coordinate and this is our y coordinate. But when we find the gradient, we're interested first of all in the change in y divided by the change in x. So my change in y, these are my y coordinates. I'm going from -5 to -2. So if you think about a number line, if I'm going from -5, I'm getting bigger to get to -2. I'm going up 3. That's positive 3. Look at this one, the x coordinates. I'm going from -5 to -3. So again, we're going up the number line. We're getting more positive, less negative. So that's +2. Okay. The reason I've put them above each other like this is to make sure we're always going from this coordinate to that coordinate. It's very tempting to make both of them positive, even if one of them's negative. So we've got 3 over 2, which we can convert to 1.5. We could leave it as 3 over 2. And it's positive because positive divided by a positive is positive. And if we just look at that quickly, I'm not going to use a ruler. We've got exactly the same as we did before. Okay, I'm going to do one more example with a negative gradient in using the coordinates rather than the rather than the grid. So my first coordinate is -5, 4. My second coordinate is -1, 1. Okay, this is my x, this is my y. To find my gradient, I do my change in y, 4 to 1. Well, that's going smaller. That's -3. It's going down 3. And now I look at my x change, -5 to -1. Now, although the number's getting smaller, the value's getting bigger because they're negative, so that's actually going up 4. So we've got there -3/4. Because it's negative and positive, my answer will be negative, and I can leave it as a fraction, 3/4, or I could write it as a decimal, 0.75. If we look, yes, that is going downhill, and it's not very steep, so that does make sense for the gradient.